Once again, a very good evening to everyone. So, welcome everyone for this 2 hours KickStarter session to digital forensic investigations. Fine. From Kriyavan Cyber. So, what we are going to discuss for the next 2 hours, we'll be seeing some concepts, we'll be seeing some keywords, we'll be seeing some tools and techniques. As the name goes, this is going to be a Kickstarter for digital forensics. If you want to pursue a career in digital forensic or in layman terms, cybercrime investigations, what all the basic things we need to know, we'll be covering this in this 2 hours. I hope all the participants who are completely attending the session based upon the analytics from MS Teams, all active participants will be provided with the certificate in a day or two. Okay, so we'll just quickly jump onto the session. So the session is about Kickstarter to digital forensic investigations. And fine. So we'll start with an example. So what you see here on this screen, something like zeros and ones on the left hand side of the screen. Some wordings, October 25, 2024, something happened on that day. BDDASN, you knew, some keywords, you see. So if I say you that left hand side is equal to right hand side, in this example, just like we prove theorems in maths, physics, likewise, I say LHS is equal to RHS. Being a beginner, you're going to hear what is digital forensics. If you're interested, you're going to get into digital forensic. For your understanding and betterment, I've just given you some color codes. White color belongs to white color in left hand side and right hand side. Same is applicable for black and yellow. And to be precise, you note the yellow color, which is there on the left hand side. You see the binary representation 0 followed by 1, 2, 3, 4, 5, 6 ones followed by 0. So 1 plus 6 plus 1, totally 8. Right? So whenever you see something like this on a data, a device, right? So the conclusion is in ASCII equivalent, this is corresponding to this symbol. If you are seeing this symbol for the first time, this is called as a tilde symbol. The symbol will be available in your keyboard below, exactly below the escape key at the top left corner, right? So this is the theorems are proved. Left hand side is equal to right hand side. So what is the conclusion? Whatever we write, we see it is not only the wordings, it can be audio, it can be a video, it can be a whole data, right? So left hand side is the computer language, whatever computers are able to see and interpret, zeros and ones, bits and bytes. Right hand side is human readable language, right? So if you see what is there on the right hand side, you will be able to clearly say, hey, this is October 25, 2024. But if you see the white color zeros and ones on the left hand side, just it's copied in a notepad file and given to you. We should be able to interpret. Typically it's called as an encoding, converting from one format to other format. We should be able to do. So that's what we try typically in digital forensic. That's a general misconception. Whenever someone delivers a lecture on digital forensic, they used to say, like even I had that when I was delivering some early sessions, right? So digital forensic is recovering data, recovering a missing, deleted or hidden data. That's a part of digital forensic. In digital forensics, obviously, yes, we do recover the data, but data recovery is not completely digital forensic. Digital forensic is far beyond data recovery alone, right? So that's what we see here. Left hand side, you see computer interpretable language 0 and 1. Right hand side, we see human readable language. This is what we do. We do with a notepad file, we do with an audio, video, even greater evidences, right? We call it evidences. You take a pen drive, you take a hard disk, you take a cloud data, all things in digital, we call it as a digital evidence, right? So if you are able to understand this, what is in left hand side and what is in right hand side, how to equate this, you got to know like what is digital forensic or how to do an investigation, right? That's the first step. Fine. Again, all about me, you might have seen, known about me, right? Ashok Kumar Mohan. You have my details, personal details or my whole of the curriculum in my personal website. You'll be able to find that in akmohan.in. And we are from Kriyavan. Kriyavan is a cyber forensic private limited company. Our core is on digital forensic. We do investigate, incident response, VAPT, GRC sort of cybersecurity related services, and we have a vertical on R&D which we deliver training and investigations. So fine. I used to be visiting faculty at the university and also be the founder director at the company. So for more details, you'll be able to find it in my personal page, akmohan.in. That's my personal page. And this is about us. Fine. So with this short intro about me and company, right? So we'll quickly jump on what you are going to do for the next two hours. Fine. So that is first 30 minutes. What is digital forensic? At the end of the session, you get the certificate from us. You go and put it in your LinkedIn. You just put it in your Instagram. Some of your friends might ask, a recruiter might ask, hey, you claim that you have done a couple of hours on digital forensic from a company. You uploaded your certificate also. Well and good. What you learn? Or else let me know what is digital forensic. In first hand, let me know what is digital forensic, right? So the first 30 minutes will make a crystal clear idea about what is digital forensic and what are all the components of that. Second half, we'll be seeing keywords and jargons. So the second slot, we'll be checking about keywords and jargons, right? So that's the main difference between these two. Just giving a 2-mark definition of what is digital forensic, and in depth giving, let's say like today we'll be introducing you to some 10 keywords. If you hear these 10 keywords, if you are able to define these 10 keywords in your own language with an example, someone will accept saying that you know something on digital forensic, at least in a beginner level or an intermediate level. So second half, we are going to see some keywords and jargons. Third, we are going to see something on steps in digital forensic, how to perform a digital forensic. And finally, some tools and techniques, the tools of trade which are most commonly used in digital forensic. Some open source tools, some commercial trials, or some paid tools, right? So that's going to be the agenda for the whole 2 hours. Fine. So, but you see this something on the right hand side of the screen, which is highlighted with respect to the thing. Learn, know how, practice, investigate. This is a model, the learning model, the learning curve we appreciate here, right? Because 30 minutes you learn, you say like, sir, I learned driving. 60 minutes you will come to know, I know how to drive. Say you buy a brand new car, you just give it to someone. You are hiring for a driver. One driver says, sir, I learned how to drive. Another driver says confidently, sir, I know how to drive. Whom you will give the car? You will give it to the second person because his confidence level and his expertise will just let you know like he can handle the car in the right way. Same way, learning and knowing how is different. You take irrespective of digital forensic, you learn any topic in computer or out of the box, right? Learning something, writing a 2-mark, 8-mark, 16-mark, clearing a course, that's different. Knowing how, practicing it, putting into real world thing is the thing which expected in companies for any skill set, right? So we'll just cover these two things. And this session, again, we'll start with a disclaimer. This session is for newbie graduates, cybersecurity enthusiasts who wants to learn or who are interested in to knowing like what is cybersecurity, what is exactly in digital forensic, right? For newbies. And clearly, this session is not for if you are already into investigation, you have handled some cases, you work with police, or you know have tools and expertise, you are a CHFA certified, or you are a cyber geek knowing about bug bounty, or cyber geek something who knows about hack the box, any of these things. This session might not be for you. Maybe it might be interestingly boring, right? This is not an expertise level course. Shortly giving it in 2 hours, fine. So again, you see the 3 guys on the screen. Most of my favorite guys, right? The guy on the center is called Kevin Mitnick, world top 1 hacker. Then Adrian Lamo, Kevin Paulson. These 3 are the top 3 hackers of the world of all time, starting from 90s till today, right? So they are the top 3 hackers. That's what to just portrait experts. I've just given their photo. And with this indexing, we'll just get on to the session, right? We'll start with what is digital forensic. Fine. The keywords and jargon part. So I'll just start with a meme to show something meaningful, right? The meme says the awkward moment when you go for a handshake and the other party go for a hug. You see 2 national leaders are meeting. One leader gives a hug, the other leader goes for a handshake. What does it mean? Both of them does not know the protocol of the other country. Protocol means that's the standard, right? So every country, every religion, every ethnic will have different means to say hi or give a welcome. Fine. So the same thing is applicable in digital forensic also. You learn a tool. Let's say today we'll be seeing a tool called autopsy. If you claim that I know how to use autopsy, fine, well and good. But with autopsy, you can just analyze only Windows or Linux systems. You cannot directly jump onto a advanced mobile or a server or a RAID or advanced systems with the normal tool. So learning about tools, techniques, knowing the basics is fine, but the protocols has to be followed everywhere. Typically in investigation, you need to know what is your evidence, you need to know what tool technique to use, what are the better means, typically the standard operating procedures to do that. Then finally we'll just take, we'll do a lot of field work. You might have heard of sharpening the knife before cutting the tree, right? Same way, when we call something on digital forensic or a real world cybercrime investigation, before getting onto the crime scene, before touching the evidence, we do a lot of field work, right? In pen and papers, that might not be portrayed on any of the movies you see people doing crime investigation or digital investigations, right? Yeah. Again, we'll start with the principle. You see, something is appearing, something is disappearing, something is appearing, something is disappearing, left and right. You see a knife, and right side you see a lady face, but hair is portrayed. In traditional forensic, knife with some fingerprints, hair particles, some dust, bullets, right? Everything will be treated as an evidence. That is called as a traditional forensic science. So that's a principle as you see here on the screen. The name of the principle is Lockett's exchange principle because it was formulated or created by a person called Dr. Edmund Locke. What the principle says in a nutshell, just in 2-3 words, right? Every contact leaves a trace. Just like we study Pythagoras theorem, we study Newton's laws, right? This is called as Lockett's exchange principle. Not only for digital forensic, this principle is applicable across any forensic, whatever we're talking about, traditional forensics on blood stains, DNA, blood shoots, everything, right? Every contact leaves a trace. That is called as Lockett's exchange principle. If you want me to brief it, in a crime scene, any contact coming into the crime scene will leave something in the crime scene. Any contact going out of the crime scene will take something from the crime scene. While coming in, you leave something. While going out, you take something. It can be a dust, it can be a hair particle, it can be a small piece of something that is sticking onto your dress, anything like that. Fine. So every contact leaves a trace in a crime scene. That is called as Lockett's exchange principle, formulated by Dr. Edmund Locke. He is called as father of modern forensic or Sherlock Holmes of France. Right. So with that, we are going to see not much of definitions in the sense about digital forensic. We are going to see a couple of definitions related to digital forensic. The first definition is about what is a digital footprint. The second definition is going to be obviously what is digital forensic, right? So we'll start with what is a footprint. To be precise, digital footprint. What you see here on the screen, Facebook, YouTube, LinkedIn, WhatsApp, all your social medias, Google like search engines, maps like Safari and navigators, right? Mixer stuff, right? So this is what called as digital footprint. As the name goes, you go browse something on the internet, offline or online, or else you just open your laptop, do some activities, even offline, right? This is called as a digital footprint. According to a definition of Wikipedia, we have broken down into unique parts. It's a unique set of traceable digital activities. You browse, you share, you email, you tag someone in GPS, right? So you are doing some activity, a unique set of traceable activities, fine. It can be action, adding, deleting, modifying. It can be a contribution, you are uploading a photo, downloading a photo. It can be a communication, you call someone, say hi, hello in WhatsApp or anywhere or over an email, right? Traceable digital activities, actions, contributions, communications. Where are you doing all these things? We are doing this in the internet or on the digital device, right? So the unique set of traceable digital activities, actions, contributions, and communication that are manifested on the internet or on any digital device is called as digital footprint. Fine. The first definition, it's clear. Digital footprint means all activity we do, just like we saw on the first slide, right? Everything will be stored in your digital devices, online or offline, with respect to zeros and ones. Fine. Now we'll jump on to the actual definition of digital forensic. And before we start with this, I'll throw you a disclaimer. There are many definitions, overlapping definitions. Digital forensic, cyber forensic, computer forensic. All these things are overlapping. I don't want to confuse you with giving all the topics, all the definitions. Today we'll see what is digital forensic, and they are overlapping topics, say way the similar. Right? So digital forensic, in a nutshell, someone asked, hey, you had a certificate, you uploaded it in your social media, you claim you know digital forensic. Digital forensic is the process of finding and analyzing electronic data. The same way we saw on the first screen, right? So you're finding a data and analyzing the data. You find zeros and ones. You say, hey, this is a photo, this is an audio, this is an email, right? So that is called as digital forensic. Finding and analyzing electronic data is called digital forensic. And if someone asks, hey, fine, well and good, just give me some brief definition of digital forensic. I have an extended definition for you at the bottom. We will read the way in which it is formulated. The goal of process, digital forensic is a process, fine, is to preserve any evidence in the most original form. Let's stop, right? So you're not going to define digital forensic now. Before that, the definition gives you a disclaimer. Hey, you do digital forensic, fine, well and good. Before that, there's a rule. We call it as a thumb rule. You solve a case, you see, like even at Kriyavan, we just Jane and Dave would work with cyber forensic related case request or service request, right? So out of 100k services, we might have solved 10, 20 services, no problem. But the 80 services unsolved might be in some mixed ways because of lack of resources or because of out of scope, right? But we follow a single procedure in all the 100 cases or all the 100 service requests which we proceed is the first thing. Preserving the evidence in the most original form. What does it mean? Evidence in here we discuss is not bloodstains, DNA. The evidence which we discuss are something like this: a laptop, a GPS receiver, a camera, a SD card, a pod, a smartphone, a smart device, anything, any device which is capable of storing, retrieving, and transmitting data. So before you start with what is digital forensic, we start with a disclaimer saying that hey, before you investigate, fine, you need to preserve the evidence in the most original form. You go to the crime scene, you find a hard disk today evening, like 6:24 p.m. So the hard disk which is got by you, an investigator, today evening at 6:24 p.m. is typically a most original form, right? And we need to preserve the evidence. So whatever keywords which you are seeing now, I hope before the end of this session, you'll get a clear picture of what is preserving, what is the original form and everything, right? So the goal of the process that's called digital forensic is to preserve any evidence in the most original form. Well and good, we have preserved the evidence. What is the next step? While performing a structured investigation, we do a structured investigation. We go to the crime scene, collect, identify and collect and validate the digital evidence. Why we are doing all these things? Just like you see in the movie, someone says what happened last week, Friday, this date, this time. In movie, they will rewind and show. Typically, we are going to reconstruct the past event in a digitally sound manner that can be produced in the code of law. So preserving the evidence in the most original form and investigating to reconstruct the past event, that is called digital forensic. And technically speaking, it is collecting, identifying and validating the evidence. So the goal of the process is digital forensic is to preserve the evidence in the most original form on the first hand, then perform a structured investigation, collecting, identifying, validating the digital information for the purpose of reconstructing past event. Keep in mind, digital forensic is a post-mortem analysis. What does it mean? We are going to analyze what happened in the past. We are not going to do any prediction or threat intelligence, right? To see what will come in tomorrow or day after or 6 months later. Digital forensic is purely a post-mortem analysis. You will be given a hard disk, you will be given a pen drive, you will be given a Gmail login. We need to do an investigation, a post-mortem on the data for what happened in any past, right? So that is about digital forensic. You got a couple of definitions: finding and analyzing data, preserving the data, doing a structured investigation for reconstructing the past event. These both definitions will give you a clear picture about what is digital forensic. Fine. Now we'll move next. Okay, how to do this? It's already mentioned structured investigation. What does that mean? You go to the crime scene. Let's say a crime happened in your company. There are like in the premises or in that block or in that room, there are 50 computers available. First step is identification. Identify the evidence. You go to the crime scene. We are not talking about traditional evidence. We are talking about digital evidence. You go to the crime scene and identify the evidence. Here there are 25 computers. What are the storage mediums that can be there in the 25 computers? There can be a hard disk, there can be a RAM, there can be a pen drive connected to the device, there can be a network storage, everything. Fine. So identification, just like you go to the traditional crime scene and find someone is dead, you find a knife, you identify knife as an evidence, blood stain as an evidence. Same way in digital forensic or computer forensic, we talk about storage data or storage units which are capable of storing evidences, right? So identification is the first phase in digital forensic. You go to the crime scene and identify the evidence. After that, you should not collect the evidence and preserve it. That's not a standard procedure. You need to preserve the evidence and collect it. You would have seen that, right? A police will put a brand new white kerchief over the knife and take it. What he is doing? He is preserving the fingerprint in the knife. He don't want to keep his fingerprint and destroy the old fingerprint. He'll put a knife, he'll put a kerchief over the knife and take the knife. That will be sent to the forensic lab. Fingerprint will be analyzed. It will be produced in the court of law. Same way, it can be a pen drive, it can be a hard disk, it can be any of the online logins, right? You need to preserve the evidence after identifying the digital evidence. We need to preserve the evidence, then go for collecting the evidence. You cannot do everything in the crime scene. You collect the evidence, take it to your forensic lab in Madurai, Chennai, Hyderabad, Delhi, and with tools, techniques, lab setup or forensic lab setup, you do the investigation, right? So after preserving and collecting, processing, reviewing, analyzing, this is what a tool does. Today we'll come to know different tools, right? So you give a pen drive to a tool, you give a mobile to a tool, you give a cloud login to the tool. It can be a open source tool, it can be a proprietary tool. What the tool will do? The tool will process the data for you, it will analyze, it will review the data, it will analyze. What does it mean? You're given 50 hard disks from your company. I want to know what was the mail sent on last Monday. Analyzing all the 50 mails, the processing all the data, 50 hard disks, each hard disk is 1 TB, 50 TB of data. Reviewing, my review is I want to know what happened last Monday. So reviewing based upon timeline, then analyzing. I don't want all the data on that Monday. I want only the email files in all the 50 devices that was sent in and out of the company on that Monday. Fine. So that is processing the data, reviewing with respect to the crime, and finally analyzing the data. Any open source or paid tool will do this. After doing this, we go for production. Production in the means, right? Producing a report, a written report, or else a printed form of a report. Sometimes forensic report starts from 2 page, 5 page, 100 page, even 1000 plus pages, right? So producing a report, and final thing is called presentation. You go to the court and say, hey, I am an investigator. I analyzed this hard disk. I know this email was there. It was deleted by someone. I recovered it using this tool, standard tool, and I have made my forensic report. That's called as a presentation. So starting from identification to presentation, right? This is the complete workflow of what is called as digital forensics. Fine. Okay. So we got a definition of one-liner digital forensic, complete digital forensic, and we have seen the structured steps in digital forensics, right? Now we'll start with the keyword, right? For your understanding, due to the time limitations, right? If you're taking a complete 40-60 hours course, we'll be discussing all the keywords individually. But today, valuing the fact of time, 1.5 hours, right? So we'll see some 10 keywords. If you know, if you claim, if you say, I know digital forensic, you should be able to define this 10 with proper example, right? We'll start the keywords. The first keyword, or before knowing that, what is a keyword? You see here, this is a report from a case document, page number 7 out of 102. Scott Friedberg did identify the Microsoft Word document in which Mr. Seglia claims to have copied and pasted a purported email. All of the Word documents were backdated. It's a report, right? You read it, you understand. But the important keyword here is purported email and backdated. Technically speaking, what does it mean? Purported email. The email was sent yesterday, but the date was saying it was sent on January 2nd, 2024. What does it mean? The attacker might have changed. Purported means modified. purported email that was clearly backdated. It was sent one day before, but somehow the attacker or have somehow modified the evidence saying that the email came before 15 months or last year January. Fine. So that we'll see some top 10 keywords which will be useful for you at any phase of investigation. The first and the foremost keyword which we are learning today is carving or file carving. Okay. Carving or file carving in cyber terminologies, in data recovery terminologies, or in digital forensic terminologies is called as art of recovering something. Something is missing, something is hidden, you take it out. Fine. So practice of searching an input, file or other kind of object, what we are doing, just like we saw in the first slide, only 010101 something is there. You are searching for an input. Hey, I want a photo. I want a document. Or I am searching for a video file. Fine. And other kinds of object. Again, you are searching for an input or an object based upon the content. Let us say it's a 2 GB pen drive. The pen drive is formatted. You recovered the data. All data is only 010101, right? What does the definition says? You are searching something. You are searching for audio, video, anything. You are searching based upon the content. Content means the data available in the device rather than metadata. What does it mean? You are not searching a metadata, you are searching the actual data. You keep this keyword in mind, metadata. Shortly we'll see what is metadata. Fine. We'll skip this part. We'll take this part alone. Practice of searching an input for a file or other kind of object. Let's say I am giving you a notepad document, 1000-page notepad. I am saying that there are 10 photos inside this. Only 0101 is there, right? Then what's the conclusion? Inside that file, there are 10 photos available. Fine. So we'll see this with an example. What you see here on the screen? Can someone say what you see here on the screen or type in the chat box? What is this visually? How it looks like? How it looks like for you? Fine. I saw someone is requesting for a Tamil session. Fine. Sorry, pardon me. Many of them are connected from other states also. We'll have it mixed English now. If you want it in Tamil, you can request, you can just arrange for a separate session. Certificates will be mailed for all active participants who are staying for the whole of the course. That will be verified by the team and will be sent. Fine. Okay. We'll come back. So what do you see here on the screen? Can you type on the chat box? What do you see here? Visually, what is displayed on the screen? Let me zoom out. Okay. What do you see here? How it looks like day in and day out. Carved data. Someone might have already learned this. Fine, well and good. In layman term, you see what you see here. A computer user, not a cyber, not an engineering student, right? So how it looks like? What type of file is that? Any guess? I hope that's the most common file which we use. Document file, obvious. MS Office, docx file. The file will say, hey, I am a doc file. If you are using a latest version, it will say, I am a docx file. Fine. So it's a document file. What is inside the document file? There are some wordings and there is a picture available, right? So let us assume this was the experiment which was tried for file carving. There was a pen drive. Inside the pen drive, many data was there. Along with the data, this pen drive is also there. Sorry, this Word document is also there. Let us assume a 2 GB pen drive. In the 2 GB pen drive, many data are there. This Word document is there. Inside the Word document, there is some wordings are there. Other than wordings, there's a photo is stored in the Word document, right? It is available in the pen drive. Let us assume that the pen drive is active. You open, if the document name is Despicable Me, the document will say, hey, I am Despicable Me. My size is 10 KB. I am available in this first folder. All these things are called metadata. You remember? We discussed earlier. You are searching the file based upon content, not on the metadata. Metadata will clearly say, just like you, it will give you a roll number. Anyone coming to your college wants to find you, 12001 Cyber Department 2022 admission, they can clearly able to find you. Without knowing that, if I say, hey, I know someone who is tall, who is fair, who is 20 years old, who is coming from this city, We won't be able to find unless and otherwise we do some intense investigation. Fine. Same way, the pen drive is there, many data are there, it is formatted. We have taken the pen drive into custody. We have just recovered the data in the pen drive, but we are not able to recover the Word document, right? Let us see. We get data something like this. Fine. Like this. See? The data in computer terminologies will be represented as hexadecimal. Hexa means 16, 0 to 9, A to F, 16 values. You see here EF, 8A, 9E, D4, FF, 0, 0. Everything between the value of 0 to 9 and A to F. Fine. Yeah. So again, we have said the pen drive is formatted. In the pen drive, we have recovered the data. We have recovered in hexadecimal, zeros and ones, bits and bytes. All the hexadecimal value is here. Fine. I know this crime scene. We should recover a photo. Fine. You see here, I am searching inside the content for a keyword. In cyber terminologies or forensic terminologies, we call this as magic keyword. Go on Google for magic keyword FFD8 FFE0. It will clearly say, hey, welcome. You are searching for a JPEG. You are searching for a photo file format. The magic keyword or the keyword which you have mentioned is a photo file format, right? So in the whole of the data, we are searching for this. The result says, hey, welcome. There are 14 results found. Conclusion, there are 14 photos that may be available in the data, in the deleted drive. In this, it's showing one data which is available on offset number. You see here, bottom left corner, offset in cyber or offset in investigation is typically similar to your chair. You go to a movie, seat number A1, A2, A3. Same way, offset in cyber terminologies is the location where the data is stored. So we go to offset number 14FD. 14 means 14A0, A, B0, C0. We'll walk down, right? 14A0, B0, C0, D0, F. Fine. F0 is there. Let us see. F0, F1, F2, F3, F4, F5, F6, F7, F8, F9, F10, F11, sorry, F9, FA, FB, FC, FD. Likewise, when you sort it out, it will come FD is this per. You see here, left side F0, at the top D. When the F and D combines, this is the place where the signature is there. The magic keyword is there. FF, D8, FF, E0 on the next line. What's the conclusion? This is computer language. Binaries, hexadecimal, computer readable language. This is one tool which we use in forensic called as hex editor. It will show you what is the human readable language. Provided the data is not encrypted or locked, it will show you the human readable language. It clearly says, hey, welcome. There's a JPEG file available. You see here, JPEG. It is able to identify a JPEG file inside this data. Clear. We have understood that the deleted photo is available. The next step is you have known the starting point, right? We need to know the ending point. The ending offset of this JPEG format will be 2ADB. Starting we have already found 14FD. So if you know like your friends are sitting between chair number 12 to 21, what you will do? You will call all people from 12 to 21. Same way, in this you copy the data in 14FD, starting from 14FD, all the data ending in 2ADB, then copy paste it in a Word document, typically a notepad, not else MS Word. Open a notepad and copy and paste it there. Then go to file and save as. We know it's an image document. Go to file, save as a recovered image .jpg. If you are doing this operation, whatever you have discussed for the past 10-15 minutes is called as file carving. If you are doing this file carving operations in the right way, obviously as you can see here on the screen, we should be able to recover the deleted photo or delete it irrespective. It can be a photo, audio, video, Word document, anything. For your identification example, we have just taken an example of a photo. So the first file signature, file signature is something like somehow type about a file signature, right? I'll type it in the chat box. FFD8. Fine. You see here, you're asking for a file signature. FFD8. D8. FF E0. Someone have asked for the file signature. I am typing in the chat box. Okay. So this is called as file carving. The first keyword you are learning today with respect to digital forensic is called file carving. Next keyword is called disk imaging. When someone says an image, hey, image, I am sharing you image of a function, 100 images. What is the conclusion? We assume 100 photos. Fine. If someone says I am giving you an image of OS, they are giving a bootable OS, Kali Linux or Windows or Ubuntu in pen drive, 4 GB ISO file, that is called as another image. So whatever image or imaging in digital forensic or disk imaging, when you hear the keyword image or imaging, typically imaging in digital forensic, it is not the photo. What does that mean? It's not the bitmap photo which we use day in and day out. No. It is not the ISO file which we use to make bootable. BMP is also called as image. ISO file is also called as image. But in digital forensic, image is something like this. Visually convincing, what you see here on the screen. If you are seeing this for the first time, this is the opened hard disk. When you unbolt your hard disk, not current day solid state, this is older hard disk, platter based hard disk. When you open a older type of hard disk, it will look something like this. A CD like object, a head needle like object will be available. How many hard disks you see here? Can someone type in the chat box how many hard disks you see here in this? Some numbers which you see on the screen. How many number of hard disks you see here on the screen? 1, fine. Maybe the left one. 2, fine. Something is partially faded, right? So to just give you an example of imaging, imaging in digital forensic is typically a copy of your evidence. Again, not just like we copy paste in folder, we copy paste from pen drive to pen drive. This is called as bit by bit copy. You take the pen drive, 14 GB pen drive, from the first bit till the last bit, just like we saw in the first image, from the first 0 till the last 0 or 1, right? So that is called as disk imaging. Fine. Disk imaging in digital forensic is creating a sector by sector copy of your source medium. Fine. Just a minute. Okay. So disk image or imaging is typically a bit by bit or sector by sector copy of the source medium. You have a 500 GB hard disk, imaging 500 GB means it's called an image of a hard disk evidence. You have a 16 GB pen drive, imaging a 16 GB pen drive means you have a 16 GB copy of your original pen drive, right? It's irrespective of the evidence, it's applicable for every devices. In generic terms, we call it as imaging. So what we have learned, let me type in the chat box. First keyword is file carving, fine. Okay. Second keyword is disk imaging, fine. Okay. So the next keyword which you are learning, which you are going to see is called as write blocker. To give you a better understanding about write blocker, I'll let you know. Write blocker, we can take an example of one-way traffic. We might not follow here in our roads, right? But typically a protocol, the definition of one-way traffic says you are allowed to travel in one direction, but you are not allowed to travel in the other direction. Same way in digital forensics, when we talk about write blocker can be a software, it can be a small piece of Perl Python code that can restrict your data from writing a data to the device, or it can be a hardware. It can be a hardware write blocker. Fine. What does a write blocker means? You are going to image the disk as you saw in the second definition. You are going to image the device Fine, as you have seen in the second definition. But you're going to use it in the right way. As we saw in the definition of digital forensic, we need to preserve the evidence in the original form, right? So for that, we'll use something called as write blocker. You see here, acquisition without damage. Acquisition means imaging without damaging the source. Whatever you see here, a small device, you can imagine this like a portable hard disk in your palm size. This is called as a write blocker, a hardware device. Table is the one of the leading manufacturer company manufacturing write blockers across the globe for forensic. Fine. So how in real world write blockers will be used? The same diagram. Typically a photo taken from a crime scene or an investigating unit. Fine. So how many devices you see here? Maybe left side. Let's walk through from left to right. Left side, you can see this is a hard disk, maybe a 1 TB removable hard disk. The hard disk is connected to a laptop. In cyber terminologies, forensic terminologies, we call it a workstation, a laptop or a computer in which the forensic softwares are installed. So hard disk is there, a workstation is there. Again, the workstation is coming, a white color wire is coming. The wire is connected to another device called write blocker, just what we saw on this previous image. From the write blocker, another wire is going. It is connected to a source hard disk. Let us say in your office, you have taken a 500 GB hard disk. To consolidate things, you have a workstation, you have an empty hard disk on the left hand side, you have the evidence hard disk on the right hand side, and in between these, you have connected a write blocker. Fine. As per the rule, write blocker will allow traffic from one direction and it won't allow in the other direction. Conclusion is, I'm going to copy the data from right to left. What is? You are going to copy the data from this device to this empty device. And we need to make sure not any single bit of data from this empty device, a single bit of data from your workstation, or any data from the pen drive that is connected on this device is going to be written on the source medium. To make it clear, fine. So you are going, this is the hard disk that is seized from the crime scene, 500 GB hard disk. You want to make an image of the hard disk. Image means exact copy, bit by bit copy. So left side you are getting a empty hard disk. Again, when we talk about imaging, if you are going to image a hard disk, 500 GB hard disk, another 500 GB empty hard disk won't do good, because 500 GB means when you go my computer, C drive, D drive, 500 GB will show usable as 497 GB, 495 GB. It will show something like that. It won't show the whole 500 GB. Some data will be there for firmware, some data will be there for other system properties or device properties. So if we want to image or copy a 500 GB hard disk to an empty hard disk, the empty hard disk should be minimum 1.5 or 2 times greater than the original source. Copy a 500 GB hard disk, I need minimum 750 GB or 1 TB hard disk. To copy a 4 GB pen drive, I need at least 6 GB or 8 GB pen drive. Fine. So that is the form of imaging. We have seen a definition called imaging. Then now we have seen a definition called write blocker. Fine. The third definition which we have seen here, the keyword is write blocker. Write blocker can be a hardware or software, fine, which we use in the crime scene to make sure the evidence is not modified. Okay, fine. You are doing all things properly. Disk imaging with the proper tool. While imaging, you are using a write blocker. That is fine. Then what is the important takeaway? The important takeaway is this thing. Something called as hashing. You are imaging a 500 GB hard disk. You claim that the data is not overwritten. But how to ensure that 100% of data is copied from the investigating hard disk to the empty hard disk? And it can copy 70%. It can copy 99.99%. Fine. It can stop at any phase. So for verification of that, we use something called as a cryptographic algorithm or a technique called as hashing. H-A-S-H-I-N-G, hashing. Hashing is a technique to verify integrity. Integrity means, I'll give you a layman term example. I'm saying, hey, meet me at 6. You are receiving the message, meet me at 9. What is the conclusion? The message is modified. So while sending, if I hash the data, meet me at 6. The hash will give me an output like this. 288D6 starting and ending at 8B. If you are receiving the same message, you do the hashing in your device with the same MD5 hash algorithm. It should give you the same result. From this, you cannot construct the data. You cannot get the data. It is only for checking. So before and after, when you hash, if the hash is matching, the conclusion is meet me at 6 from the receiver side. Meet me at 6 from the sender side. Have gone to the receiver exactly as meet me at 6. If there is some change, the whole hash will change. And technically speaking, first line 1, 2, 3, 4, 5, 6, 7, 8. 8 in a row, 8, 16, 24, 32. 32 bit, right? So typically this MD5 algorithm, which we are discussing here, it will take any data, maybe a notepad, audio, a video, a hard disk, everything, but it will give only a single hash value, only for verification. Fine. You see here? Hashing is a cryptographic function mapping an arbitrary size to a fixed size. Any big number of data will be the same number of hash, or else the length of the hash is going to be the same. It is irreversible. It's not the compression. You are not compressing a 700 GB file to 400 GB file. It is only a verification mechanism. How it works? You see, the dog, hash value of the dog 8A230. Hash value of brown dog runs down the hill. This is the hash. The brown dog leaps down the hill. This is the hash. You check both hashes. Some wordings are changed. The hashes are completely different. The conclusion is, if the hashes before and after are changing, the data is modified. If the hash before and after are the same, you see in this example, original hard disk at the top, hash starting with M7 and 89, ending at N9. The cloned hard disk or imaged hard disk at the bottom, hash starting with M7 and 89. The conclusion is, you are doing a imaging, you have used the write blocker, you are using hashes, and you are able to do the imaging or copying the evidence in a forensically sound manner, right? So that's what is called as hashing. The fourth keyword which we learn here is hashing. Fine, we'll go to next. Fine, hashing is done. Okay. Again, to verify the hashes, there are many online hash checkers available. You see here. To verify the hashes, just a minute. Yeah, to verify the hashes, you can use any number of hash checker. This is a tool, MD5 tool, hash checker tool. The sender is sending a file called softpdr.txt. You are receiving the file. The sender have sent you the hash value saying that the hashes are many different algorithms. MD5, SHA-1, SHA-2, different hash algorithm. Let us assume I am using MD5 algorithm. Starting with CD, ending with 7B. The receiver is calculating the hash. If it is matching, starting with the same CD and ending with the 7B, the conclusion is hashes are not changed, the file is not modified. File in the sense, it can be a 6 GB movie file, it can be a 16 GB pen drive, it can be a 500 GB hard disk. You take a complete hash of the evidence. Fine. So, example, many websites, when they put a big file online, Ubuntu is giving the ISO files online. They give the corresponding hash values also. After downloading, you can verify whether the hash is matching or not. So the next keyword is file format. What does it mean? Excel sheet, PPT, document, PDF. That's a file format we know, right? Day in and day out, we use these file formats, right? But file format in forensic is E01, AFF, S01, RAW, DD, E01. Fine. Many file formats are here. The top 10 file formats are listed here. I'll just introduce you to 2 or 3 formats, right? RAW format is just like what we see on the first screen. 010101, some hexadecimal value. That's a raw format, like a raw meat, uncooked one, right? Not organized data is called raw format. You have a pen drive, the pen drive is formatted, 2 GB pen drive. When you recover data, it is showing 1.7 GB. The 1.7 GB, the bits and pieces of data, torn data you have in hand is called as raw data because it doesn't have a data structures. Fine. If it is stored in a format, I'm storing a pen drive, input file as 16 GB pen drive, output file as image sample evidence.dd. So DD is one format, data definition, and there are many other jargons for DD, confusing DDs, right? So this definition says data definition. File name.dd says it's a evidence file or image file. In forensic, we call this image file. File name.e01 is a evidence file. File name.dmz is an evidence file. DMZ is typically with respect to Apple device, MacBook. If you're imaging something in MacBook, you'll store it in DMZ. But for matter of fact of time, you keep it in mind. Raw DD E01. Raw is the open format. DD is the like free format available in any Linux systems. E01 is the paid tool. It's come with a tool name called Ncase. When you are imaging a pen drive with the Ncase tool, the Ncase tool will say, hey, where you want me to store the file? You give desktop. In desktop, it will show the 16 GB pen drive.e01. Fine. This is the forensic file format. So whatever data we are imaging, copying the actual evidence, we don't store it as a notepad or document or PDF or PPT. We store it in unique forensic file formats. Whatever you see here on the screen are unique digital forensic file formats. I have listed very few. There are hundreds of file formats. These are all the most commonly used file formats. At least these formats we need to know when we talk about digital forensic. Again, something interesting. The next keyword, affidavit. Fine. Phi is DD or E01. Okay. Sixth definition is something called as affidavit. Maybe a legal term. Some of the lawyers might know what is this affidavit. Let us see this with a meme. Example of affidavit with a meme. What does it say? Mom wants me to write an affidavit. Couldn't be done because I'm a major. You see, this guy, a kid, 6 months or 1 year. Fine. So what we do with kids? Typically the kids, those are crawling, those who go to school 1 year, 2 year. They'll break something. We'll ask them to write something. I won't break this. They will write their name and give. Tomorrow if they are breaking that again, we cannot do it. We won't do anything. We can beat them or we can just being harsh with them. But the written document with the kid is giving, nothing can be proved in court of law, right? Something like that is called as an affidavit. We are talking about what is not an affidavit. That is a kid one. Actually, affidavit is a formal written document by signed and sealed by witnesses. Fine. You see here in this affidavit, an example of affidavit is shown on the screen. State of Texas, affidavit by Jane Doe. Jane Doe says, hey, I am a sysadmin. I know Sarah Smith is my company employee. This date, this time, she have taken the company laptop or device out of the company. Fine. What is the conclusion? This is an affidavit given by the system admin Jane Doe. It is signed and sealed by Joe. If needed, you can go for a notary public. You know, right? We get signed with green ink with some notary public or government officials. So that is typically called as an affidavit. Affidavit in digital forensic or any forensic is a written statement. How an affidavit will look like? What is affidavit? This is an affidavit for a search warrant. If you want to search someone's company, you need to get an affidavit from a court. Because we traditionally follow US and UK standards. This is a sample affidavit from a UK standard. Fine. Yeah. So the 60 definition is affidavit. The seventh one, the important one which we need to connect with first definition is called metadata. Easiest to mark in any engineering course, right? What is metadata? Data about data. What is the metadata of an image file? Ashok.jpg. The name is Ashok. It is stored in my hard disk. It is stored in my laptop. It is stored in the desktop. It was taken on January 1st. It was copied to my computer on January 22nd. Fine. All details about the file. Typically, when you select a file, right click and go to properties, you will find the basic metadata. And they have standards. What you see here at the bottom, EXIF, exchangeable image file format. EXIF is a standard for image files, typically photo files. You don't confuse this image with forensic image. This EXIF image is typically photo format standard. Okay. We'll see what is this. What you see here on the screen. Who are they? Any guess? Recently, we might have just witnessed many attacks in north of India, Jammu, Kashmir, right? How this photo looks like? Can someone comment in the chat box? Maybe a couple standing in front of Taj Mahal romancing? No. Terrorists, right? Okay, their look and feel, their shirt, their costume says someone has a gun in hand, looks like a terrorist. What's the background? What is their background? Background in the sense the scenery, how it looks like, place, geographical location, hill station, obviously looks like a mountain, fine. Okay, just a minute. Looks like a hill station. So this is actually a photo taken from a camera. When we extract the metadata of this photo, the metadata is called as exif. The standard is called exif. Inside the exif, what it will be there? You see some interesting juicy information. Here, this photo was taken using a Canon E05 450D SLR or DSLR camera. The photo resolution is this. It was taken on 2008 morning 9:06 some standard time. Fine, well and good. Even more interesting data is latitude and longitude. 36.16 north, 69.96 east. For your understanding, I'm opening Google Maps in another tab. Let me go to Google Maps. We'll see what data we have seen. 36.16, 69.96. I'm typing in Google Maps. If you are searching this for the first time, this is how we search coordinates in Google Maps. 36.16, obviously the northern direction. And what next? 69.96. I'm ignoring the other digits just to save some time. 69.96 east. So 36.16 north. If you want, I'll remove the space. 36.16 north, space, 69.96 east. Let me click on enter. It's going to list a place. Let's check where exactly is it. Let's say the layered view or map view. How it looks like. Mountain. You see on the left side, some location, Askin-Bala, Afghanistan. What's the conclusion? So this photo has had a metadata. Fine. So the photo which you have taken, which you have seen, has a metadata. Metadata have all information. But when we talk about metadata, because current day we are just sticked on with social medias, Facebook, Instagram, Messenger. I'll throw you a disclaimer. When you take a photo in your camera or mobile, when you upload it in any social media, you put it in Facebook, you put it in your Instagram, you put it in WhatsApp, download the photo again. The right side properties column, you won't find anything. Everything will be erased. The photo camera, 0. Photo resolution, 0. The photo name itself will be changed. You can notice this. You upload a photo from your mobile into your WhatsApp, you download it again. Before and after, you verify the metadata. Before, it will show 100 metadata. After that, only 10 metadata, that too, the dummy name given by WhatsApp. Well, keep in mind, metadatas, whatever I'm showing here, will be intact unless and otherwise the file is not modified. Not only for photo, you can take a metadata for audio, you can take a metadata for video, you can take a metadata for any file. But provided the metadata is intact. Metadata is so sensitive. When you download, when you open and close, when you copy from your laptop to mobile, pen drive to laptop, the metadata changes or metadata gets modified, right? So that is called as metadata. Data about data. Fine. It follows a standard called EXIF. EXIF standard is given here. Fine. The seventh definition which we have seen here is metadata. Fine. The eighth thing, the interesting one, perpetrator, perpetuator or perpetrator, different vocabularies, we call it in different names. But we'll see what exactly it is. Let's start with the definition. A person who carries out harmful, illegal or immoral act. Typically in our terminologies, we call it as a criminal. Right? Criminal who commits a crime. In cyber terminologies, insider employee, a disgruntled employee, a state-sponsored cyber terrorist, activist, everyone who committed cyber crime, knowingly or unknowingly, for good or bad purpose, anyone who commits a cyber crime is called as, or crime is called as a perpetrator. Fine. Let me puzzle you with a photo. You see a guy who's rounded off in this photo. This guy is the owner of a game. I'll say you a famous game. I'll say you the game is something threatening. Can you name a game something like that? Famous game, threatening game, serious game. Leave your PUBG and Free Fire, right? You rewind back to 3 years, 5 years. Exactly. Someone have typed blue whale, blue whale, blue whale. Obvious. This guy, Philip Budakin, from proclaimed to be from Europe or Russia, right? He is the owner of Blue Whale game. Owner means he is the guy who coded the APK for Blue Whale game. You know, Blue Whale game will have 50 challenges. First challenge, you tear your hand. 50th challenge, you jump from the top of the building. So this guy is a proclaimed owner. When a case is filed, he'll be called as perpetuator, criminal, convict, right? So perpetuator in technical terms or legal terms is called as a person who commits a crime. Fine. So there is a 8th definition which you have seen. Perpetuator, criminal in a crime scene. The last two, the important ones we are going to see is slack and swap space. I have combined these two to a single definition. SLACK space SWAP. Two definitions. We need to read it side by side to understand both the definition. Slack space, swap space. Fine. Let us see what is slack space at first. Let's go zoom, zoom, zoom. Leftover storage, unused storage. You see this example? You are creating a Word document, leave letter.document. Let us say your OS or your hard disk is assigning you a storage. When you create a document, storage will be assigned, right? Let us take a unit. Unit means 1 unit. How many units are allocated here? 1, 2, 3, 4 units are allocated. How many units we have used on seeing the diagram, blue color? 2.5 we have used. Another 1.5 is unused. Let it be a Word document. Let it be a PDF. Let it be a photo. What is the conclusion? When you create a file, your OS or your hard disk will allocate you some space. They won't allocate you 1 byte, 1 byte, 1 byte. They will allocate you in terms of 2 to the power x. 2, 4, 8, 16. How much is allocated? 4 is allocated here. That is called as physical space. Total usable space. How much you have used? The logical space, 2.5 is used. The left out unused space in any storage medium is called as slack space. Why we are hearing or learning about slack spaces in digital forensic? Hackers or attackers or criminals, those who commit a crime, are not beginners. They might be in this domain like you and me for the past 10, 15 years. They know how to commit a crime without leaving any evidence. But evidences will be there. Just like we saw in Lockett's exchange principle, every contact leaves a trace. Some evidence will be there. But they will try to erase all the evidences max to max. So that's what slack space is. Unused space. If you are having 10 Word documents in your desktop, today you go, click any document, right click on property. It will show you 2 space. Size of the disk and size on disk. 2 storage will be there. Size on disk 4 KB. Size is 2.5 KB. How much is allocated for you and how much you have used? Right? The unused space is going to be unused. If you are using above 4, 4.1, another 4 bytes will be allocated to you. Fine. That is the policy followed by OS data structures. Fine. So that is called as slack space. That's a separate domain called slack space forensic in which we do investigation on slack space. Fine. Okay. So the next thing is called as swap space. Again, in digital forensic, when we talk about storage, hard disk is the main storage. Your laptop has 500 GB hard disk. Fine. How much RAM? You have 8 GB, 16 GB RAM. Whenever your OS boots, I have minimized a Word document, I have minimized MS Teams now, I have minimized my WhatsApp now. All my data, whichever I minimized, whichever I am using, a copy of the data from the main hard disk where the OS is installed will be copied into my RAM. After some time, after processing, it will be again coming back to my hard disk for storage. And processor is also involved. We are not talking about processor here. Now we are talking about the data moving between hard disk and RAM. So this data moving between hard disk and RAM, a copy of the RAM, is called as swap space. SWAP. Swap space is the typically a copy of your RAM that is stored on the hard disk. Where you can see here, if you are a Windows user, go to Windows, open my computer. In my computer C colon, in C colon you will find 2 to 3 files. Swap.sys, hyperfill.sys, right? 2 or 3 files in the name of .sys extension, SYS extension will be there. Those files are called as swap and slack space. So you have seen 9 definitions, and the last definition keyword which you are going to see today is 10.COC, chain of custody. The important thing in digital forensic is chain of custody. It's a chronological document. What does it mean? You born, you studied LKG, UKG, 10th standard, 12th standard, BTech, MTech. What is the chronology? You are arranging it from smaller to greater. If it is greater to smaller, if you ask me, hey, I am doing PhD, I did MTech, I did BTech, I did 12th, I did 10th. I am saying you in the decreasing order from highest to lowest. In any order, you arrange something that is called as chronological order, some order, fine. So you go to the crime scene, you get many data, you get a pen drive, you get a hard disk. In a pen drive, 10 photos are there, in hard disk, 100 photos are there. All the evidence you need to analyze, right? Chronology means boy meets a girl, falls in love, gets married, that's obvious. World War 1, 2, we don't expect anything on 3. Chronology means putting in a specific order, right? So chronological document, chain of custody, how it looks like. You see here, subject, case number, date, item 1, pen drive. Item 2, hard disk. Item 3, Gmail login. Item 4, another removable hard disk. Fine. This is the record. Date, time, recovered, received. And today, this time, recovered from Madurai in my company, received by an investigator. It is taken to Chennai lab. Chennai, who is receiving, which date, which time, it has to be signed. From Chennai, it is coming back to Madurai lab. From Madurai, I am sending it to Delhi again. So this is called as movement register. You know, right? When you go to a courier agency, you put a courier, they'll track your courier. They'll track your shipment or actual parcel. So this chain of custody is a chronological document which is going to track your evidence. It's going to track, you got an evidence now, after 3 months you go and produce it in the court of law. What happened to the pen drive in the last 3 months? Day wise, step by step, whenever you do any activity, right? You'll also put some tag, right? You go to a shop, you find a price tag, 1000 rupees, 2000 rupees, same way. For all evidences, we'll put an evidence tag like this. So chain of custody and evidence tag are important part of digital forensic. Fine. I hope we have done and dusted with the top 10 keywords, definitions. Fine. So we'll just quickly walk through a tool, right? I won't be able to open all the tools, but today we'll walk through a common tool. Let me open, just give me a couple of seconds. I'm opening a tool called Autopsy, AUTOPSY. Fine. Let me project it to your screen. Fine. Yeah. Just a minute. Sorry. I hope the screen is blank. Let me. Just a minute. There's some display. Just give me a minute. Let me sort out the display issue. Okay. Fine. I'm opening Autopsy again. So whatever keywords which we have seen now, the 10 keywords I've typed in the chat box. Quickly, meanwhile I open this tool. You just go to the chat box and read the 10 keywords. Whatever I have discussed, whatever definition examples I have given might come to your mind. Right? Just read the 10 keywords. Let me open this. I hope the autopsy screen is visible. A dog, the screen. Is it visible? Yes. If you give me an yes, we'll go next. Yes, thank you. Okay, this is a tool called Autopsy, a publicly available open source tool. Whatever you have seen, the 10 keywords, investigation, the analysis space. You give an evidence, it will analyze and give you the report. What it is doing, see, let us create a new case. Fine. I'm creating a new case. Case name, fine. CFIR V1 demo, fine. I'm storing the case in a folder. Let me click next. It is asking the case number. In companies, will have case number. For example, SRXX of Kriyavan, created on 3rd May 25. Case is created by Mr. AKM. Phone number, company, all details about the investigation, and finish. Once when you click on finish, what it will do, it is going to create a case directory. You see here, it is showing creating a case directory database. In that folder, my documents folder, in autopsy folder, it is going to create a new case. Fine. Okay, it's loading still. Yeah. Just a minute. I've uninstalled the tool and reinstalled for your understanding. So it is popping up 3 times. Let me open it. Just a minute. Autopsy tool is open. Sorry. Okay, fine. So what next? It will ask, hey, you have created a case. What do you want to do next? Generate a new host. Fine. Let me give default. I'm creating a new host. So this is the important part. What you see here on the screen. This is the imaging phase. Do you remember we discussed about disk imaging? What do you want? You want to open an image. Already you copied a 6 GB pen drive or 100 GB hard disk or a local disk. I want to investigate C colon, D colon. Fine. Or a logical file. I want to investigate only my desktop folder. Unallocated space, or else already created an autopsy case, or else X or Y, another tool. So in this, what they are asking, hey, I am an autopsy. You are asking me to investigate. Give me the input. What do you want me to investigate? Let me select logical files. Click on next. Let me locate a folder. What we do by default, we'll select a disk image. A pop-up will come. Fine. Click on disk image. Click next. Path, browse. I am selecting it. A pop-up will come. You see at the bottom, supported file formats, whichever we discussed in the example, IMG, DD, E01, PMDK, all forensic formats. You can, if you already imaged or copied the evidence, you can import it here. For time being, to save some time, I am creating a logical file. I want to investigate only a specific folder. We'll just select a folder. I'm clicking on to add. I'm clicking my, for your interest, opening my, maybe my documents, let it be. I'm selecting this folder. I'll select a folder called CFIR demo. Select. I've selected a folder. Let's assume inside that folder or inside that file we are doing an investigation. You see timestamp to be included. Metadata. I want to include all the timestamp and click on next. This is interesting, please. Hey, I am an autopsy tool. You want me to investigate? What do you want me to find? You see something at this photorec. Photorec is a tool for file carving. The first definition which we saw, right? keep corrupted file, focus on all files, right? So photo rec is for recovering photos, email parser is for recovering emails, hash lookup is for verifying hashes of viruses, extension mismatch. You created a Word document, then the criminal have renamed the Word document to PPT. When you double click, it says unknown PPT format. When you rename PPT to Word document, the Word document is opening. Someone might just do some renaming of the file, so that also can be detected. Embedded file, one virus sitting inside another virus. Picture analyzer, typically metadata analyzer. Many fields will be here. You can select all and you can click next. Fine. It will process for a while. My data source is added. Well and good. When I click on finish, the case folder, case directory will be created. It will start analyzing the folder which I gave. You can give a folder. If you are giving, fine, there are some error. I just uninstalled it twice. Cyber triage license could not be found. I don't want triage now. I'm running only this tool. Okay. Just a minute. There was some. So it's an open source tool, right? I have just tried uninstalling, installing a couple of times in the past 2 days. So it's popping some errors. Okay. Maybe meanwhile that is opening a search. Let me open the online version of that. Just let's check on to this server. I'm opening the autopsy's website because there were some issues here. So for your understanding, I'm opening the autopsy's official website. KickStarter guide. The same thing which I was doing should be here. Fine. So the actual autopsy window will look like this. We'll wait whether till it loads in my system. Fine. So autopsy tool, when you open, it will analyze your case, right? Left side, it will give you details about, hey, what is the case? 2000 photos, 39 videos, 138 audios, deleted files, mismatch files, temporary files, search based upon a keyword, everything will be there. At the top, you see, add a data source. You can add a data source. You can view images and photos. You can put a timeline. This pen drive has data between 2020 and 2025. You can see what all the data that has been copied in all the 5 years. Again, a disclaimer, you cannot recover all the files, right? The timeline will give you only the file name or file metadata. It's up to you to do file carving or recovery to recover the file completely. Then finally, you can generate a report. Hey, in this case, download that link, hacking into computer, link something in Arab language. These are all evidence. You select as evidence and click on generate report. It will generate the report. So this is one of the most common publicly available open source tool for digital forensic investigation. Fine. You see, when you select each and every file, it will show at the bottom. You remember we discussed this in file carving, hexadecimal view that will be shown. Fine. So this is the tool. Let me say about hash online. We discussed about hashing, right? Because write blockers, I cannot show a demo because it's a physical device. Fine. So hashing will check hash online. I am checking an online hash calculator. You can give an audio, you can give a video, you can give a photo, anything. I am giving a keyword Ashok, all in small. Algorithm is MD5. Hash it. The hash says VB 2D and ending it 43. Let me copy that. Open a notepad. Let me paste that. Fine. I'm pasting it here. The whole data. What is this? This is the home hash using MD5 algorithm. There are many algorithms available for hash, not a single algorithm. Algorithm. This is the output of the hash value. Fine. What is the input? Input is Ashok. I have given a keyword. Output is this hash value. Fine. Simple. So in the input, if I am changing something, instead of K, I make it as a capital K and calculate the hash. The same Ashok is there, right? But you see the hash, I am copying this hash, the same MD5 algorithm. The input is modified. Let's go back to the document. Let us check the hash value of ASHO capital K. You see the hashes before and after completely changed. BB21D, B160 ending with 43, ending with 4A. Some similarities might be there, but the hash is changed, right? The hash is completely changed. Fine. So this is called as hash or hashing. We discussed about hashing. Fine. So the hash algorithms. Fine. So autopsy. I hope the tool is still rebooting. It will ask for a reboot. I don't want to reboot my PC now. Fine. Wait. Okay, let us keep the tool. We'll bounce back to. Okay, this is how our tool works, right? So autopsy tool will have an input image. It will automatically hash. It will analyze your evidence. It will make a report. Whatever we have seen in this steps, right? So if you want it in a structured way, right? The steps in digital forensic, you see here. Seizure, acquisition, analyzing, reporting. 4-step model. That's a 7-step model. That's a 9-step model. That's a 5-step model. It's depending upon the author. I have created a 4-step model based upon the cases which we handle or the evidences which we handle. The first thing is called seizure. Seizure means go to the crime scene, identify the evidence, seize the evidence. What does that mean? Someone have taken a photo, their mobile has to be produced in the court of law. Whether they will give, hey, take my mobile, arrest me. No, they won't give the device. That's what in legal terms that is called as seizure. Seizing means capturing or getting it from someone forcefully. So identifying and seizing the evidence is the first thing. When you seize the evidence, if it is hard disk, that's a method to preserve. If it is a pen drive, that's a method to preserve. If it is a mobile, that's a method to preserve. We need to preserve it while collecting. Without preserving, if you collect the evidence, there is no use. At the end of the day, all your investigation will go zero. It won't be accepted in the court. Fine. So keep in mind, as per the definition, while collecting the evidence or before collecting the evidence, we need to preserve the evidence, right? If you take a complete course on digital forensic investigation, you will come to know how to preserve a hard disk, how to preserve a pen drive, how to preserve a email evidence, how to preserve a cloud evidence, right? Everything we'll learn step by step. Acquisition, after preserving, what we do, the 10 steps we have seen, right? You use a write blocker, use a hash value, that is for authentication, verification. After that, acquisition. What does that mean? Creating an image. Imaging is making a copy of the pen drive or hard disk. Again, how many images to take? For example, you have a hard disk. How many copies you can take? As per the law, again we follow US UK standards, right? So as per the forensic standards, you need to have 3 evidences or 3 image files, right? So let me show you like this. Okay. As per the standard, I am talking about 500 GB HDD. We need to take 3 images. Images, practically speaking, 3 copies of the evidences in different devices. Whom for the 3 copies? The first copy is for original plus first copy. You're not going to touch this. It's important. You're not going to touch this anywhere. You're going to produce it in the court of law. Fine. Second copy is the perpetuator copy, right? Perpetuator means if an opponent, right, or anyone who's involved in the case, if they ask, you need to give them a copy of evidence. You cannot say like I won't give you the copy, right? And the final copy, the third copy is called as investigator copy. You are an investigator, you make third copy. If you want, you make additional copies. So bare minimal, how many copies we take? Practically speaking, in real world, we take only one copy. Fine, in any cases, right? But if it is a high sensitive case, as per the standard, if you follow, if you want to go to court for investigation proceedings, you need to take minimum 3 copies, 3 evidences, right? So all with hashes, verification, right blocker, everything, fine. So that is called acquisition, creating duplicates, copies of evidence. After acquisition, analysis. After analysis, reporting. Analysis, what we do? We will verify the evidence with the chain of custody. We will validate the evidence with the hash value. Then we will analyze. Analyzing means searching and recovering. In this analysis phase only, the tool comes. You see, like we have seen the autopsy tool, right, which we opened, right? So the tool comes into place, right? The tool will get the evidence as input. It will analyze. All investigation will be done. It will give you the report. But being a forensic investigator, you need to know, or we need to know how the tool works. We cannot blindly believe the tool says 2 files recovered, okay, accepted. The tool says only 1 file recovered, accepted. No. We need to logically know, just like we are seeing from the first, file carving, imaging, hashing, we need to clearly know how the tool works. Fine. Yeah, that is analysis phase. Final is reporting, document the chain of custody. If we have taken some evidences, that's an area called disposal of backup or disposal of evidence. We will see this in a complete course, right? There's a separate study on disposal of evidence with respect to privacy laws. Fine. Finally, make a report, the forensic report. Then you go to court and talk as an expert witness or present as an expert witness. So this is called as steps in digital forensics. We have seen an introduction. We have seen some keywords and jargons. We have seen steps in digital forensic. Now we'll jump on to the tools and techniques. When you take a open course, anyone who is in a beginner level newbie trainer, right, who's offering you a course, they will directly start teaching autopsy. They will directly start teaching volatility, right? But whatever you have seen, some basic concepts, if it's a complete course, we'll see this in depth, right? Without knowing all these things, if you are directly starting with the tool, let's say first day the investigator opens autopsy, the images hashes. Being a beginner or newbie, it will be a tough nut for you to crack or understand. So autopsy, this tool, we are seeing about tools of trade, tools and techniques for investigation. I've listed only obsolete older tools in the slides, right? Maybe mixer tools. Autopsy is the open source tool, free tool for investigation. Then bulk extractor, as the name goes, you give 50 hard disks, ask them to extract all the mails. Bulk extractor will extract all the mails from all 50 hard disks. As the name goes, bulk extractor is the tool name. Volatility is memory analysis. We saw a copy of the RAM, right? Copy of the RAM or copy of memory, volatility will do. Oxygen forensic, leading in the market. Mobile analysis tools. If you can keenly peep into this photo, it is say, as you see in movies, right? Hey, this person, Simon Pike, is a criminal. He is communicating with many persons. He have made 24 calls to Jason, 31 calls to Patrick, 33 calls to Cook. I want to know how many calls Simon made to Lars Jackson. So that's what is listed here. They both have discussed on Skype, what all the Skype chat, even if Skype is encrypted, some tools are capable of recovering the data. I'm in a meeting, sorry, I'll call you later. What we'll do now, fine. All discussions about, this is typically an iPhone, right? iPhone 4S, that is given as an input to this tool. The name of the tool is called Oxygen Forensic Investigator Tool. It will give you complete data. Logs, calls, messages, missed calls, deleted photos. We are talking about the mobile. Anything you can recover from mobile, this tool is capable of doing. Volatility, Mandiant is another tool. They do memory analysis, they do threat intel, right? So Mandiant tool is used for image or memory analysis, paid version of tool. Encase, Visa Autopsy, free tool. Encase is the paid version of the tool. It can do all operations. Kane is a portable operating system which will have all things. You see, when you open my computer, you see MS Office, MS Paint. In Kane, you see here, they have Guy Major for imaging, they have autopsy, they have hex editor, they have photo recovery, they have hashing tool, they have image viewer, they have image mounting tool, everything is inbuilt. A single OS with all forensic tools inbuilt. Older OS, older version of OS is called Kane. This is a field kit. Really interesting. When you go to the crime scene, if you are a part of an investigation, you carry the suitcase like thing. This is a Celebrite. You see here, if you can understand what we discussed earlier about right blocker, that is reflected here. Let me zoom in for you. Let me zoom this. Samsung phone. You are investigating a Samsung phone. You are copying the Samsung phone to an empty hard disk. This is connected to a workstation. This is a portable workstation called Celebrite. But wait, where's the right blocker? You remember right blocker was there, right? Right blocker is not visible because this is a highly paid workstation. So inside this suitcase like this box setup, at the back of this itself, right blocker will be there. So you see all types of connectors, USB to type 1, type 2, type 3, A, B, C, all type of connectors will be there. This is called as field kit, right? Portable kit. You can take it to crime scene for investigating or taking evidences. Celebrite. Explico is a network forensic tool. You analyze network. Kali, the so-called hacker OS, has some forensic tools also. Then SANS DFIR. SANS is a global organization, research group. Now we are talking about hard disk forensic. Currently, SANS is working on Bitcoin, blockchain. They are working on drone forensic. They are working on satellite image forensic. They are a research group. They have released their own version of OS with all forensic tools. SANS DFIR. This is a hexadecimal tool, just like an X-ray machine. It will show what is inside your data or what is inside your pen drive or hard disk. Then DFF, open source framework. Parrot, another OS, completely loaded with forensic tools for investigation. Theft, another forensic OS. All these things, mixed tools. I have listed the open source, categorized the paid tool. NKS, Paraben, Oxygen, Helix, Celebrite, Mandiant Redline. Now another company have acquired this Redline. Fine. So these are all paid and free tools, right? Standards, we are not going to go in much, right? So from the first, I am talking about evidence, an image, evidence of a pen drive, evidence of a hard disk, evidence of a different devices like mobile or anything. But sir, this is the first time I am doing investigation. Give me a sample of evidence. I want a 4 GB pen drive sample. I want a 500 GB hard disk sample. You will find it in this website. CFREDS, Computer Forensic Reference Datasets by NIST. They have all sample evidences for learning analysis. Fine. Okay. So we'll go next. From the first, what we have seen, introduction, a couple of definitions for digital forensics, top 10 keywords. Just a minute. Okay, fine. So we have seen intro, we have seen 10 keywords, we have seen the steps, we have seen some tools, right? In real world, irrespective you are from UK, US or India or any country, when we talk about digital forensic investigation, a course in digital forensic investigation, a process in digital forensic investigation, these things has to be followed. Because you go and get a paid tool, autopsy, a free tool, a paid tool, in case, the tool will do everything. You give the hard disk, you give the pen drive, sit for 20 minutes or 1 hour, the tool will do all investigation. But company or government agency, wherever you apply for a job, they want you to know all these things. In a nutshell, whatever that can be covered in 1 or 2 hours, that is discussed here, right? What next? Wait, let me show you. If you want to get into digital forensic, from my understanding, right? I've been teaching this forensic over a decade from 2010, right? 10, 12, 15 years, right? So anyone who wants to learn about digital forensic, get a job in digital forensic, or at least for knowledge base, if you want to learn cyber investigation, you need to know about web technologies. You need to know to interview a suspect, right? You need to know about the laws, practical knowledge of investigation, how the tool works, thorough knowledge of the logs, interesting part, ecosystem. You are getting a pen drive, you are getting a hard disk, your data is stored where it is stored. GAFM, G for Google, A for Amazon, F for Facebook, A for Apple, and M for Microsoft. GAFM. These are all big players in the market, right? Without them, you cannot talk about a data or storage. Working knowledge of cryptography is art of hiding, typically art of converting from plain to text to ciphertext. Locking and unlocking is crypto. Steganography is hiding, unhiding is steganography. Password recovery, you get a mobile, the mobile is locked with the password. What to do? You cannot recover a photo without unlocking the mobile. So password recovery, file system, latest cyber attacks, the finally thing is right, out of the box thinking. You are an investigator, you are a hacker, you know everything, fine. You should be able to think out of the box. What does it mean? An investigator thinks to, right, you might have heard in movies. To catch a criminal, you should know how a criminal works. How to catch a criminal, you should be a criminal, or you know how the criminal activities happens, right? That's out of the box thinking, fine. These are all the mandatory requisites if you want to get into digital forensic. Obviously, these things you need to cover, fine. You need to learn all these things. What we have seen today, now the bird's eye view of digital forensic. You see here, a eagle. It's looking at something. We don't know what the eagle is looking at. It's prey. So today we have seen what is digital forensic. Top 10 keywords, definitions, keywords, jargons. That's well and good. Fine. Let me move to the disclaimer part. Fine. The same thing. Yeah. You see here, I have a disclaimer. Again, whatever I discuss now are all my personal opinions from my experience, from my learnings, mistakes, right? All image source which we discussed are to the owners, images, photos displayed, fine. So sharing is security, happy sharing, fine. So whatever we have discussed now is all about what is digital forensic, right? How to do, how to work, fine. So you have any questions, queries till now about what is digital forensic in a nutshell? That's what we call this session as KickStarter to digital forensic, fine. So because we have just initiated this Kickstarter session to just give a chance about speaking about our full course. Maybe from next week or week later, we'll be offering a complete course on digital forensic investigation. That's called CFIR, Cyber Forensic and Incident Response version 1 course. Again, we'll have it for 25 days. Whatever you have seen in this 2 hours, we'll see it bit by bit, depth by depth, tool by tool, all the 25 days, one domain, email forensic, image forensic, dark web forensic, Bitcoin forensic, network forensic. We'll see it day by day. Fine. So if you want to know more, right, again those who participated for the whole of this 1.5 hours, I hope we are nearby to 2 hours, right? You might have got to know what is digital forensic, how it works, right? So there will be a participation certificate. After verification, it will be mailed to your email ID, your registered email ID, maybe on Monday. Tomorrow is not a working day, fine. Hopefully, Monday it will be mailed to your registered mail ID. If you want to know more about this, if you want to pursue cyber forensic as a career, or else if you want to learn digital forensic for knowledge purpose or understanding, right? So you can just very well get in touch with the team. I hope everyone knows about Kriyavan's support number 97 1930 1930. Again, the details also will be mailed to your email with the certificate. Fine. So what we have seen today, we have just, in a nutshell, we have just quickly walked through what is digital forensic, right? So bits and pieces of digital forensic we have seen. Fine. If you have any questions, queries, you can put in the chat box. How to get an internship as a fresher in digital forensic? Interesting. That's a question. Again, many companies don't encourage freshers for a job, but internships are there. You see, even now, Indian government, Maharashtra cell have called for an internship. Gurugram police have called for an internship. The type of Gurugram police, right? They have an internship called for this month for digital forensic. They'll have an interview. They'll select you for internship. Police people will be sharing their experience, teaching you for tools and techniques on digital forensic. Again, if you want to get into digital forensic, for sure, they'll expect, even we being a startup, we hire candidates will minimum 6 or 1 year experience, 6 months or 1 year experience. Fine. So you need to know whatever I've shown, the tool, the technique, how to operate, and it's case by case or evidence by evidence, it is different. It's not like the single tool will analyze all evidences. A tool for MacBook, a tool for Windows, a tool for Linux, a tool for Android, different tools are there. You need to know, when you do practice, only you will know which tool to use for what evidence. There's not a single all-in-one tool will investigate everything. Autopsy is a common tool, fine. Beginner level we'll learn autopsy tool or NCase tool, but we go advanced, we'll use the specific tool. Hey, I'm investigating a MacBook Air M1 chipset. The MacBook Air is this format. Then Black Widow, a tool will work which can investigate the MacBook alone. Fine. Yeah. Hopefully we are at the end of the session. Fine. So if you have any questions, queries, I'm happy to answer. I repeat, all the active participants, those are available till now, right? The certificates will be shared to you in Gmail, to your registered Gmail on Monday, the next working day. Fine. Internship at Kriyavan, obviously, we can just, I'm typing in the chat box 9719301930. We can contact our training head. She'll let you know because she's taking care of the intern. She'll let you know what all the opportunities available here. Whether you want to know about this course or anything on digital forensic or what all the opportunities available at Kriyavan with respect to digital forensic, you can contact our support team that I have typed in the chat box. Kriyavan Cyber 9719301930. Team will guide you on what next. Fine. So if you have any generic questions, I'll go up the chat box. I hope I've answered all the questions in the chat box. Yeah, Kali Linux gives the so-called hacking tools. Obviously, it will give you the forensic tools also, all open source tools inside the framework. Okay, let me stop my screen share. Fine. I hope I've answered all the questions in the chat box. Thank you all for spending your time on weekends, Saturdays, coming here to understand about what is digital forensic. Fine. Thank you all. We'll be in touch. If you want to continue on learning in digital forensic, you want to know anything about digital forensic, you can contact our support team. Have a great weekend. Thank you all. We are ending the event for all.